A very good morning to all lecturers, Sir Wilson. My name is Alexander Uzen King. 05DAD22F1016 are my matrix number, and they are my group member Muhammad Amirul bin Idris and also Zhong Yang Cheng. We are from DAD1A and subject code are DJJ10033 Workshop Technology. Today we are going to present about distortion in welding. What is distortion? Distortion in a weld results from the expansion and construction of the weld metal and adjacent base metal during the heating and cooling cycle of the welding process. Doing all welding on one side of a part will cause much more distortion if the welds are alternated from one side to the other side. Let's move on to the effect. Effect of shrinkage in various types of welded assembly. The magnitude and distribution of shrinkage and distortion in a welded structure are dependent on geometric parameters and the degree of restraint during welding. Geometric parameters such as dimension of the structure and the types and size of welding joint, and welding parameters such as heat input, welding sequence, preheat, and post-heating will affect weld shrinkage and distortion.
My name is Zhong Cheng. Matrix number is 05DD22F1061. Today, I want to present about tips for controlling weld shrinkage. First, don't overweld. The greater the amount of metal in a joint, the greater the shrinkage focus. Reducing the amount of weld saves metal, saves time, and protects the weld from distortion. If the metal plate is thicker than 0.25, relieving can help ward off distortion. 2. Use intermittent welding. Using intermittent welding rather than continuous welding, where possible, greatly decreases distortion, even though wet metal and heat transfer are reduced by as much as 75%. The standard of the weld remains relatively uncompromised. 3. Use as few weld passes as possible. Favor passes with a lens electrode are preferable to many passes with smaller electrodes. When transfer distortion could be a problem. Shrinkage is cumulative with each pass. More passes lead to more shrinkage. Number 4. Press welds near the neutral axis, providing a smaller reverse for shrinkage focus to pull the press out of alignment by pressing weld near neutral axis minimizes distortion. Number 5. Balance welds around the neutral axis. Offset one shrinkage force with another to effectively minimize distortion. The design of the assembly and squares of welding are both important factors to consider. Number 6. Use backstep welding. The general progression of the weld may be, for example, left to right, but each sequential weld segment is pressed right to the left. After the placement of each bed, the header is expanded on the first side of the weld. Once the head is pressed across the plate, expansion on the offset edge brings the plate back together. This process greatly reduces distortion. Plus, minimize welding time. Minimizing time while welding minimizes the amount of metal header, reducing hurt, reduce shrinkage, and thus distortion.
Hello, my name is Muhammad Amirul bin Idris. My matrix number is 05DAD22F1008. So, the method of distortion control. Number 1. Tack welding. Tack welds are ideal for setting and maintaining the point gap, but can also be used to resist transverse shrinkage. To be effective, thought should be given on the number of tack welds, their length, and the distance between them. The second is back-to-back assembly. By tack welding or clamping two identical components back-to-back, welding of both components can be balanced around the neutral axis of the combined assembly. It is recommended that the assembly is stress relieved before separating the component. If stress relieving is not done, it may be necessary to insert wedges between the components, so when the wedges are removed, the part will be moved back to the correct shape or alignment. The third one is stiffening. Longitudinal stiffener is the form of flat or angle welded along each side of the seam are effective in preventing longitudinal bowing. Stiffener's location is important as they must be placed at a sufficient distance from the joints so they do not interfere with welding unless located on the reverse side of a joint welded from one side. So the conclusion is, in order to control distortion, most recommended using tack weld to set up and maintaining the joint gap. Then identical component welded back to back so welding can be balanced without can be so welding can be balanced about the neutral axis. After that, attachment of longitudinal stiffeners to prevent longitudinal bowing in butt weld of thin plate structures. Where there is choice of welding procedures, process and technique should aim to deposit the weld metal as quickly as possible. MIG in preference of MMA or gas welding can mechanize rather than manual welding. Lastly, in long run, the whole weld should be completed in one direction. Backstab or skip welding technique should be used. That is all for the presentation today. Thank you.